Hey, so I wanted to make a video going over the different kinds of muscles and how I differentiate them, especially the smooth muscle and the cardiac muscle. There's sometimes a lot of confusion in that. Sorry, my husband's making fun of me. I can't stop laughing. Um, so anyways, yeah, I just wanted to go through that. I have to warn you, some of my tips may not work for all of you, but I hope that they work for the majority of you. And I'm just going to use the PowerPoint that you can download when you go to the Module 2 overview section. So that's what I will be using. Okay, so you can just download this from the overviews. It's like if you scroll clear down to the bottom, it's a download option. And I'm just going to go through it. First, I'm just going to go through the longitudinal views of each of the muscles, and then I'm going to go through the cross-section views and show how I differentiate those. So this one, it's cardiac. And what I like to look for in cardiac is these intercalated discs. They are only found in cardiac, and they're just those defined lines right there. Another thing that I like to look for, the nuclei are usually pretty round in cardiac muscle. That being said, you do have a few exceptions, like if you look over here at this corner, that's kind of a weird shaped nuclei. But for the majority of time in cardiac, they will be round nuclei. Then we have smooth. I think in the videos that you were supposed to watch, it talks about how the nuclei are cigar shape. And that is what I look for. They're usually long, cigar-shaped nuclei that are scattered randomly. There's not really a pattern to them. And that is your smooth. And then for skeletal, I look for the nuclei. They are like squished to the sides. And the nuclei are usually in a pretty straight row. And they just go down. And you also have those striations. So you have the A band, which is this dark line, and then the I band, which is the lighter line, and then inside your I line, you're going to have your Z disc. You can't really see it in this picture, but let me find another. So like this one right here is another example of skeletal because you have your nuclei, and they're all in a straight line. See what else I got here. Yeah, here's another skeletal. You have those striations where you can see that Z disc in the middle of your I band. So that's how I tell them apart in cross view. Those are just a few of the things I look for. In longitudinal section. Now we're going to go to cross section. So let me find a good one. So I guess I'm going to start with skeletal muscle and cross section. To me, it's the easiest to differentiate. So you have your the cells, and then you have your nuclei, and they're pressed to the side, and every cell has a nuclei in them. So we have them here, 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 here. And so that's what I look for when I'm looking at skeletal, is that the nuclei is pushed to the side, and every single muscle cell has that nuclei. Then the next one, this is cardiac in cross section. To me, explain this. I laugh at it every time I say it because it sounds so silly. But this is like very textured and it almost looks three-dimensional to me. It just has a lot of texture. But these also look like jelly-filled donuts to me. So here's your donut and then the jelly in the middle. And it just seems to pop out. It's not just because of the color. I guess the jelly part does. But again, this looks three-dimensional. And this nucleus is in the center. And it just looks like a donut to me. So that is how I see cardiac. Skeletal and cross-section is not quite as easy, and I've talked to other TAs, and they have the same problem describing it. For the most part, all the TAs that I have talked to, well, actually 100% of the TAs that I've talked to, we know when it's smooth muscle in cross-section due to process of elimination. So we look at it and we're like, hey, are my nuclei in the center or on the sides? So these ones are going to be like kind of all over the place. They're mostly in the center of the cells. And then on top of that, it's not very 3D looking. It's not as texturized. It just kind of has like more of a flat look, and that is what we look for. So we really just have to use like process of elimination to get to skeletal muscle. It's because we haven't really found like a good pattern to look for that gives it away every time. So hopefully this was helpful. I am willing to answer any questions that you guys may have or quiz you. Just give me a call or a text if you need anything, and I would be more than happy to help you. Anyways, hope that help made sense.